anything's possible, I guess. Even finding your own superstar explosion in space and naming it.
Yes, and we've got our very own superstar who looks up at the superstars. It's Dave Grennan!
Dave!
Guys.
Here, there's loads of space in here. There's loads of space. Sit down. Make yourself at home.
Yeah, thank you guys. Thanks for
Dave, you
on the program.
are famous for discovering a supernova.
A supernova indeed, yes, guys.
Could you explain what exactly a supernova is?
Well, I was going to say that a supernova is really cool, guys, but a supernova is actually really hot. In fact, it's the hottest thing there is. It's even hotter than the sun.
Than the sun?
Yeah, and that's
That's
so hot.
That's really hot. So how big would a supernova be?
Well, a supernova is really big, guys. For example, if we take a pea, for example. Yeah, you've got a really good pea here, guys.
Yeah.
And we take that and we imagine that this little pea is the Earth.
Yeah.
And then we take this ball.
Yeah.
And we imagine that this ball is the supernova.
The sun.
Or it's the sun. I'm sorry, you guys.
Yeah.
The supernova would be like this ball here. So it's a really, really big thing. It's, you know, Earth, sun, and a supernova. And even some supernova would be even bigger than this.
And do supernovas last forever? Are they always there?
No, a supernova used to be a sun just like this, and it exploded like the biggest fireworks in the world. Imagine if you got all the fireworks in the world and put them together and exploded them all at the same time. Well, it'd be like so much bigger than that. You couldn't even imagine how much bigger it would be. It's a big explosion.
That's really hard to get your head around that. Actually, I think we have a picture of your supernova. Let's have a look at this. Let's see what it was like when you found it in space. Is that the picture of your supernova there? There we go.
Yeah, that's the picture of supernova. It's called, boring name, 2010 IK.
Did you not get to name it? No.
Gandalf or something like that. No.
Well, it looks so small there. That's just because it's so far away.
Yes, it's so far away. In fact, it's 290 million light years. What that means is that this explosion happened 290 million years ago. Guys, do you know what was on Earth 290 million years ago?
There was no Earth.
Well, there wasn't Earth, but there was no dinosaurs. The dinosaurs
This is before the dinosaurs.
Before the dinosaurs, guys, yeah.
And how did you come about to see this? You were just like with your binoculars, or how did you see this?
Well, I've got a really big telescope at home, guys.
Let's have a look. Whoa, that's your telescope.
Hey, there's me and my telescope.
It's like the size of
and
a
that
barrel.
telescope, it is, yeah. And that telescope can take photographs of the stars at night, the night sky. And by looking at these photographs and comparing them with photographs that you've taken last week, you can see if there's any differences. And last month, I looked at one photograph, I looked at another, and I went, wow, there's a difference. There's a new star, because the supernova wasn't there before, and now it's there now, and we get to see it, and we see it for about a year until the explosion
well, I think we actually
fades
have a caller
away.
on line. Hello there, who's that?
Hey, it's Rebecca Daly.
Hey, Rebecca, do you have a question
Rebecca.
for Dave here?
What?
Do you have a question here for Dave?
Yeah.
You can ask away there.
What do you have to be good at in school if you want to be an astrologist?
Okay, Rebecca, that's a very good question. If you want to be an astronomer, one of the most important things is maths, because a lot of astronomy involves doing some quite advanced maths and being able to figure out what the universe is made of. The other thing you've got to be good at is science, and physics in particular. Now, physics is not something you would do normally till you're in secondary school, but science is something that you'll be doing probably all your school life, so pay lots of attention to your science teacher.
Now, do we have a treat for you? Yes, indeedy. All the way from Germany, we are talking to the main man at the European Space Agency, Mike McKay. How you doing?
Hey, Mike.
Hi, welcome to Mission Control.
Mission Control, how you doing?
I like the sound of that. That sounds cool.
Now, Mike, you are basically the boss of the astronauts. You tell those guys what to do. What does it take to be an astronaut?
I think you have to be a very special person, someone who's done a lot of flying, who's very good at science or mathematics, who's worked really hard in school and gone through university, and someone who's really interested in exploring and finding out new things about space and about the world in which we live in.
And with space, Mike, have you ever been in space yourself, or have you ever wanted to go up into space?
Oh, I would have loved to go in space. I remember my parents waking me to come and watch Neil Armstrong, the first man to land on the moon, and that really inspired me. But I really felt I wanted to stay with my feet on the ground and actually fly spacecraft from down here rather than actually go up and fly in orbit in the International Space Station.
Wow, you can actually fly the space satellites from Earth.
From our mission control, we can fly spacecraft anywhere around the world, or we can take them into orbits to other planets such as Mercury or Venus or even Mars. And I've been the flight director for the mission to Mars and also to the moon.
Wow. So it's basically like your job is always, it's like to control remote control satellites in space. That's unbelievable.
Yeah, it's certainly better than remote controlled cars and airplanes. Flying remotely controlled spacecraft around Mars is hard to beat.
And Doug, he's a chap up in the space station who's taking photos down onto Earth. Can you tell us a bit about those?
Yes, they started last year. It was actually an astronaut called Michael Massimino. He first started sending Twitter messages back from the space station to Earth so that everyone could start following what he's doing. And that's gone on with the Japanese astronaut last year up until June. And now Douglas Wheelock, he's been taking pictures and sending them back over Twitter. And as you can see from some of the pictures he sent back, they're absolutely fabulous. From looking at hurricanes that are coming across our planet Earth, to even looking at Ireland, that fantastic picture that he took at night, where you can see all the towns and cities in Ireland all lit up, just like a jewel in the ocean.
It really is incredible, it really is. Now, other than pretty photos, why do we put astronauts in space?
Well, we've actually had astronauts flying continuously on our space station, the International Space Station, for more than 10 years now. So there's always been an astronaut in space orbiting our planet. And the reason they're there is to understand more about how space changes the human body, how muscles disappear and bones get weaker, to see if we're going to make long-distance flights maybe to Mars and even beyond out to Saturn and some of its moons. We have to understand what effect space is having on the human body. But also we're looking at different types of medicine and different types of materials that we can grow in space that we really can't do down here on Earth with a very strong pull of gravity that holds us onto the surface of our planet.
So you're really exploring everything, but what sort of missions are you working on at the moment?
The missions on the space station, we're looking very much at materials, looking at also organisms, how setting maybe microbes and different organisms out into a hostile space environment, can they actually survive outside the space station in the vacuum of space?
This really is great stuff.
Thanks for talking to us though, Mike.
No problem, you're very welcome.
Thanks a million, Mike. We'll see you later.
Okay, thanks a lot.
Well, there you go, space explorers to the moon. Maybe in the mood for a game, actually.
You're in the mood for a game. Dave,
yes.
Are you in the mood for a game?
I'm always in the mood for a game, guys.
Are you in the mood for a game? Well, if you are, we're going to play a game I like to call Spaceball! So, Sean, will you take the performance area, please?
Let's do
Sean
this
will
fine.
put a bowl contraption on his head. Myself and Dave will throw two different coloured balls. I will throw red, and Dave will throw yellow coloured balls
What's
at
going
him.
on with this?
The person who gets the most balls in the bowl at the end wins. Can we get 20 seconds on the clock, please?
Let's go.
Start rolling the clock. Here we go.
Baseball.
Go. No, that's an awful miss. That is another awful miss.
Get in my face! Get in the ball and on my face!
Oh, he's too up. No. Tio, he's making a comeback. Ah, no. Oh, I'm winning. 5, 4, 3, 2, 1. Did he get one at the end to win? Yes, he did. Yes. Well done.
Let's
Stick
see
to
who
your
won the
astronomy,
game.
sir. It was a very good, toughly fought game of Spaceballs. Well
Let
done.
me see.
Thanks, guys.
And thank you very much for coming on the show today,
Hey,
Dave.
it's been great to be here.
I know much more now about supernovas and stars and the likes of it. Thank you very much for coming on.
You're welcome,
It's been
guys.
a great
Thanks.
show. Spaceballs, space stations, astronauts. What more could you want from a good show of Elev8?